the beach erosion on the islands of Hawaii, several islands, is about 0.4 or feet per year, or about 5 inches per year.
Okay.
And so, it doesn't seem like a lot, but the islands are getting smaller every year by about 5 inches all around.
And if they're millions of years old.
And if they're millions of years old, I think that ends up being 76 miles in 1 million years.
How big are the islands?
Islands aren't that big.
Yeah.
And so there should be no islands at all.
Hello, everyone. Welcome to the Creation Podcast, the show where we discuss the science that confirms Scripture. I'm your host, Trey, and I have with me today ICR's resident geologist and northern expert, because he is from Michigan, correct?
Yeah, the Great White North.
The Great White North.
Correct.
So we have with us Dr. Clarey. Thank you so much for being here, Dr. Clarey.
It's always a pleasure.
Awesome. Well, it's always a pleasure to have you on. We have a lot of fun here. We talk about rocks here. We're going to be talking about rocks a little bit today. Not just rocks, but more of a process that affects rocks.
Destroys rocks.
Destroys rocks.
Correct.
What, you know what we're talking about? Yes, you do know what we're talking
Well,
about.
you warned me at the top.
I did. All right. So we're going to be talking about erosion. So when I think of erosion, I think of my high school years, and they're like, erosion is what happens to, rocks and dirt, and it just wears things down, and even like concrete gets eroded. There's water erosion. There's air erosion, right? Let's just wipe all that away. We're not going to think about what I learned in high school. What do you say that erosion is?
Well, I would just say it's the removal of material, whether it's the rock or sand or whatever. It's the erosion is the actual, you can talk about weathering. Weathering breaks stuff down, but the erosion is actually the removal of that material from one place to another place.
So erosion affects our planet, and not just our planet, but I guess every terrestrial planet that's out there. But we're focused on Earth, and so we do experience erosion here.
Well, the other planets probably don't erode if they don't have an atmosphere. As
You know what, Dr. Clarey?
So,
No.
But no.
You're good.
They probably don't erode like the way we think of it. There's things that are going to hit them and go through space, and
That's
so
true.
there's going to be some impacts and things like that. And there is some.
Well, this is off topic, but aren't there storms on some planets?
Well, there are. See, some of them do have an atmosphere, like Jupiter and Venus, but Mercury doesn't really erode.
Okay, so it's just sitting there, nothing to erode
It gets really hot on one side, really cold on the other because it rotates so slowly. But other than the solar wind, maybe blasting off some. Well, if it did have an atmosphere at some point after the creation, it's gone now. So there's maybe different scales of erosion.
Maybe different.
But we're talking about Earth. So let's get back to Earth.
I love the little side tangent. Thank you, though. I don't want to be incorrect. Okay. So we have seen on our planet something very different than what we would see on the other planets, I guess. And that is rapid erosion. We see things like floods or catastrophes, whatever, that cause rapid erosion to happen. And so this kind of stands in contrast to the supposed millions or billions of years of layers that supposedly our Earth has. Specifically, I think of like cliff collapses, which is because, you see that cliff, and then if you talk to someone who's, uniformitarianist, and they'll be like, oh, that cliffside is 4.35 billion years old. Not that old. That's as old as I think the Earth is. But then, like, if it collapses, it's gone. And then it's like, now what? So we've seen, I actually have a list here, if you don't mind, a list of some of these like major collapses of cliff sides. The Broadchurch cliffs that have collapsed twice in 2017 and 2023. The White Cliffs of Dover, 2001 and 2012. The Australian coastline, 2005 and 2009. That's all just within the last couple of decades. And so that is erasing what is supposedly millions of years of geologic history. And am I right in saying that?
Well, that's correct. I mean, maybe at least
from their point of view,
hundreds of thousands or maybe even millions of years, because those cliffs, supposedly, we always were taught in school, like you were, that those cliffs erode really slowly. But when you actually examine them for 50 years or 100 years or more, we're seeing it's a lot quicker than they thought, than they say.
Right. And so these cliff collapses, these erosions, even at current rates of erosion, I see like the continents wouldn't be here at all, right? If we follow that?
Most of the continents, except maybe active mountain areas.
Okay.
So that's really what's been measured in, I think there was a study done in 2011, probably one of the more recent studies, and they showed that the average rate of erosion on the surface of the earth above the sea is about 40 feet per million years. That's their estimates. It's very slow, but over millions of years of time, it's a lot of erosion.
Right.
So you're looking at areas in the eastern U.S. that have experienced no uplift, even in the conventional time of about 250 million years or more, maybe 300 million years since the Appalachians were supposedly formed that long ago. We don't believe that, but that's what they say.
Right.
And so the area, the East Coast, the Midwest, all those areas were exposed for several hundred million years. Well, if it's 40 feet per million years, there should almost be no continent left. It should be right down to sea level in that amount of time. So if you do the math, it really adds up to a lot of hundreds of feet of erosion, and most of that area in that continent is only 500-600 feet above sea level.
Okay.
The Appalachians themselves are a little higher, maybe a little island string sticking out there, but the rest of the Midwest, my home state of Michigan, as you mentioned, that's 600-700, maybe 1,000 feet above sea level. That should have all eroded away, and including most of the East Coast should be gone. We wouldn't have anywhere to live except maybe around the Rockies, which are more recent in terms of the geologic deep time paradigm type of thing.
From their point of view, right?
So if there's no active uplift to rescue, we talk about rescuing devices, there's no way to rescue the eastern U.S. because there hasn't been any active uplift in their time, 250 to 300 million years. So why do we still have these continents all over the world that haven't been active, geologically haven't been uplifted? Why are they still there?
Right. Before we dive into some of these, like, how do they answer this? Can you explain like what today that we see, not catastrophic rates, but just standard erosion rates? What causes that?
Well, just rain, heavy rainfall will wash things away, move things. Ice, you can argue the ice age moved a lot of material around, gets caught in the ice and gets transported. Or even say wind. Wind's not very effective, just mostly for small sand-sized particles. But for the most part, it's water. Big floods, major local floods, all these types of things. You really can move a lot of material very quickly in a short amount of time. You go back to the classic studies at Mount St. Helens even. In 1982, the second eruption after the 1980 eruption, the ice that had built up in the crater melted away real quickly from this big slurry and carved about, I think it's 140-foot deep canyon, like literally overnight. And some of that was solid rock, from previous eruptions. So under the right conditions, erosion can happen really fast. If you go back to the origin of deep time, and I wrote an article about this at our ICR, it's posted on our webpage. You can do a search under the origin of deep time. It was James Hutton, and he was in the later part of the 18th century, 1790s. He was proposing the Earth is millions of years old. He was trying to get away from the studies, or the written record in the book of Genesis.
Right.
He wanted to get that out of science altogether. And so but he was looking at erosion in areas that were very, very slow amounts of erosion. And so he wasn't seeing even a rapid catastrophic event like a big major flood. He was just looking at day-to-day erosion in the fields and the hills and the rocks around Scotland. And he didn't really see evidence of any rapid erosion. So he was saying, well, that much erosion, to erode a lot of rock or deposit a lot of rock must have taken millions of years. He just threw that number out there that nobody can really fathom in their head. Try to go home and think about a million years. You can't really grasp.
I can't even think of last week.
And so, I consider it like monopoly money. You can't even, he just threw such a big number out there. And this is before they even had these, techniques where they can try to get that from their age dating, which is another whole story in itself.
Which we've talked about. We've had a podcast on dating methods.
Yeah, all the assumptions built into it. But anyway, nonetheless, that's what he saw. Yeah. And so he kind of said that's slow erosion. That's what we see. But yet we don't really see evidence of slow erosion in the rock record. We see evidence of rapid erosion in many places. is kind of the name of the game. It just sits there, and then all of a sudden a big piece of the cliff will fall off, big chunks at a time. So it's whether that's from, you want to call that the natural process over time, it is a lot quicker than what you think because it happens, big chunks will fall off these cliffs, as you mentioned, very, very quickly. And huge sections will fall off. Really, the Earth, I always say it's stuff like the Earth, like it's something, but the Earth really is built the way God built the atmosphere and the hydrologic cycle. It's built to destroy cliffs. The cycles will destroy cliffs, waterfalls. All these waterfalls we see over the Earth, all these cliffs we see over the Earth, those are temporary features. They shouldn't be there. They can't last for millions of years because they do erode so quickly. We see them all over the world. We see them in Hawaii. We see waterfalls. We see lava tubes in Hawaii. I wrote another article about that on our webpage. There's a lot of evidence in Hawaii that it's very, very young. And part of it's the waterfalls and the cliffs. Those are very temporary structures that can't last for millions of years. They should have eroded flat by now, just like the continents themselves should have been eroded down at their own erosion rates of 40 feet per year. And in some ways, Hawaii is even more interesting because you got these islands out there. They're supposed to be, Kauai is supposed to be around 5 million years old, and I think Maui is supposed to be 2 or 3 million years old, and Oahu is somewhere around 4. Give or take a little bit, but they're very small islands, and they've measured the erosion rate since 1900 on the beaches, the beach erosion, which really is the erosion. The beach erosion on the islands of Hawaii, several islands, is about 0.4 or feet per year, or about 5 inches per year.
Okay.
And so, it doesn't seem like a lot, but the islands are getting smaller every year by about 5 inches all around.
And if they're millions of years old.
And after millions of years old, I think that ends up being 76 miles in 1 million years.
How big are the islands?
Islands aren't that big.
Yeah.
And so there should be no islands at all. There should be no islands at that rate, which has been measured for over 100 years now.
Okay.
And so, you can't argue that there hasn't been any waves. You can't say the wave patterns changed, that the oceans were always there, presumably even in deep time. And so why are these islands there? The volcanic activity stopped millions of years ago on some of these islands in their worldview. So why are they still there? The only island that should be there or could still be there would be the Big Island where you still have active volcanic activity.
Creating new.
But the others should be gone. They should become seamounts like we see, further west of Kauai. You see just seamounts.
Interesting. Okay. So I've actually heard of a couple of counter arguments for this, and I'll just present them to you. Okay. And if you think that they're valid, give your opinion on them, tear them to shreds if you want. So one that I've seen is that actually the erosion rates were even slower in the past. They're much more quick today because of the way we do modern agriculture. So...
Well, and that may be a little bit of truth in that. I mean, there's, we stir up the soils more a little bit, and so you allow more of our soil to wash off, but it isn't really increasing the erosion rate of the rocks.
Okay.
People argue on the islands maybe because we're stirring things up a little bit, but you're not really eroding away. It's the waves are still the waves, and the wave action, the wave erosion is probably fairly consistent. When an island comes up, it's going to be that particular area, the waves and that latitude and longitude, that's kind of what it's been at. And, over several million years, 1 million years is all you need.
Yeah.
To them, that's nothing. And so why are there islands? Because that would be 76 miles of erosion in a million years. That's, again, 5 inches a year doesn't seem like a lot, but multiply it by a lot of zeros and you get a lot of erosion.
So you're essentially saying... agriculture could be causing higher erosion rates, but it's not enough to make a difference in the time scale.
Not that much. I mean, it's going to erode maybe a little bit, allow water access a little bit easier to some places. It might double the erosion rates or something like that. But even then, you're looking at a lot of erosion. Even if it's 2, you're looking at 35 miles in a million years.
Right.
And that's about the islands. So and if you look at the edges of the islands where they come up out of the water, and the edges where they come up because they make these big shield volcanoes that come out of the ocean, they had to build up, which I believe built up, almost catastrophic eruptions during the flood year and maybe right after the flood. But you're looking at, according to my notes, about a third of a mile in 4,500 years.
Okay.
So you're looking at, it's not that much time. That's kind of what we see. We don't see a big, huge just a little remnant sticking up and everything just planed off like you should see if those were millions of years old, maybe just a little speck or nothing left at all.
Okay.
They should just be planed off right below the wave base, which is what a seamount really is.
Right. Okay. So another, I guess, rescue device that I've seen is that the old rocks that we see were actually like shielded by newer rocks. And I guess that implies, volcanic activity, right?
Well, or you have to have a lot of deposition. You're looking at rocks that would have to be much, much, much thicker.
Okay.
You have to have thousands of feet more sediments that are just gone. And in many cases, no evidence that they were ever there. Just kind of wiped away. We believe that did happen in the receding phase of the flood, but a lot of times those rocks maybe weren't solid rock at the time, so there was a lot more erosion, I think, even of the contents as the water was receding. So the water built up, deposited a lot of sediments rapidly. As it eroded and receded, of course, we saw thousands of feet of erosion. But again, it's a major catastrophic one-time event where most of that happened.
It's not been protected for millions and millions of years.
But one other thing I know we've talked about in the past is just like in the studio here, we see these big blocks, big bricks. That's what we see. We see layer upon layer upon layer with almost no erosion in between.
Right.
When you're at Grand Canyon, they say that canyon formed, I think the current rate is 6 million years to form that canyon. But when you look at the rocks in between some of the layers, there's supposed to be a million years between these two layers and 160 million years between these two layers, and there's no canyons at all.
Right.
You got 160 million years between the Red Wall and the Muav limestones. 160 million years of time. Why is it perfectly flat?
Yeah.
Everywhere you look. And those layers
Where'd that time go?
Yeah, and by the studies I've been doing across the country, those oil wells show that those same layers continue not just in Grand Canyon, they go across the entire 48 states.
Right.
Some of them go up into Canada and down to Mexico, and the same layers are found the same way around the world. So we see these flat layers of supposedly millions of years of time between many of them, and there's no evidence of erosion.
Right.
So I challenge the deep time people to explain why is there no erosion between all these layers.
Yeah. The rescue devices are all fine and good, even if they don't make sense, but it's still, the evidence shows that that's not the case regardless. Okay. So there's even some, I guess, logical inconsistencies within the idea of this erosion of deep time. One that comes to mind is, we see things like chimney rock or other geologic features that seem very, from a geologic standpoint, they seem very fragile. And I think, in my limited knowledge, that if they were that old, they would be just like the islands, they would be gone already, right?
Right. Like Monument Valley, you see all these little remnants sticking up in places, but most of it's gone. Most of the sandstone in between those little spires sticking up is gone. We believe that's best explained by the receding phase of the flood, where huge, chunks of the sandstone were eroded away by the receding water, but they left a few remnants behind.
Right.
And so those few remnants show that there was a lot more sediment there at one point, but it's now gone. But there's always going to be some remnants when water washes off. It's often a little bit here and there. For whatever reason, this area is more resistant to the erosion, or the currents were going a different direction, or kind of swirled around something that protected it. And so you can, just like you get sea cliffs and stuff that eventually do erode away, but you get them temporarily. And that's kind of what chimney rock is.
Okay.
A lot of these features are just temporary features that, that would take today's rates of erosion are slower than the floods rates.
Which was very fast.
Right, so they're going slower, but even things like Delicate Arch in Arches National Park, same sort of thing. It looks really delicate because it is, and it's probably going to collapse maybe in our lifetime, maybe your lifetime. But it's going to. Some of these features are going to collapse. And there's a case in my home state of Michigan, the Pictured Rocks National Lakeshore along Lake Superior, and every year these guys, the boat guys, they used to take tours there with students. And every year the boat captains would come through and say big chunks of the cliff are missing. There was the winter storms and the ice. But one of the iconic symbols of that park was called Miner's Castle. It was two spires of rock sticking up about 5 or 10 feet. And one spring, one of them just slid into the lake, just cracked off, and there it went. So there's only one spire left, so it's not quite as pretty. And the same thing happened out in Vermont. Didn't one of the faces or something collapse out there in near the White Mountains? One of the old man of the some old mountain. I forget the name of the rock that was really famous, and it kind of collapsed away. So as you mentioned early on, that's kind of what's happening. We see catastrophic collapses that are more frequent than people have think about, because it doesn't happen every year,
right?
20 years, 30 years down the line, but over centuries, these things are collapsing even before our eyes today. So erosion is pretty fast. I mean, these rates of 40 feet per million years, those are just projected out, assuming conditions don't change too much. I think they're trying to take into some of the effects of an occasional storms or two that are going to increase the erosional rates. But again, it comes back to, why don't you see canyons and carved valleys and gullies in between these layers that are deposited? There's really not a lot of evidence of time between most of these layers that should be there if you believe in even this kind of erosion that they come up with. Now, John Baumgartner did some calculating. He's a geophysicist, a creation geophysicist. He calculated that you can have tsunami waves that he's modeling can erode material, solid rock, up to 40 feet per day.
Mm-hmm. That's very fast.
If you have these massive tsunami waves coming in one after the other, one after the other, like he envisions for the flood when you have rapid plate movement going on, and lots of tsunami waves generated. So you can erode really quickly under the right conditions, and you can also deposit very quickly under the right conditions.
Okay. Well, before we get to the right conditions, if you will, it's time for our random science question of the day. All right. Are you ready?
These always worry me.
Okay, good. I like to keep you worried. So you mentioned Hutton earlier today, and I think that's a prime example. Maybe not so much because he was kind of like one of the first, but when people look at rocks, why do so many people, I guess people who aren't geologists, the average person, why do rocks appear old? Why is there this idea that any sort of like stone thing that isn't man-made is so ancient?
Well, I think a lot of that's a couple of things. Number one, as humans, our short lifespans that we have on Earth, we don't see a lot of change. Most places don't experience major catastrophes, like eruptions at Mount St. Helens. If you're living a long way from that area, your terrain doesn't seem to change. We look back at pictures 100 years ago, they look almost the same. Grand Canyon looks almost the same. And so we don't see the change in our little temporary lifespan of one human lifespan at all. And we're not experiencing, unless you experience a major catastrophe in that area.
Right.
And secondly, we're somewhat brainwashed by what's taught in the schools, what's taught by geologists, what's been taught since the times of Hutton, that the Earth is old, extremely old, too old for the Bible. It's billions of years old, like you said, over 4 billion years old is the accepted age of the Earth. And so you're taught that, these rocks are old, and you go to parks and wherever you go and visit, the signage will always say, these rocks are 2.8 billion years old, and these rocks are, millions of years old, whatever. That's always kind of being thrown out there. So between not seeing a whole lot of erosion in our short human lifespan and then the constant bombardment of being told these are millions or billions of years old, everybody gets the idea that rocks are old.
Okay.
Yeah, but the rocks don't tell you time. They're just there.
You tell us.
They're just there. Well, I tell time because the Bible tells us.
Right.
That, the Earth is about 6,000 years old, and the flood was about 4,500 years ago. And everything I see in geology fits that.
Right. So we're now done with the random science question of the day.
Yeah.
Thank you. I appreciate
That was
it.
a good one.
Yeah. So you're saying the other ones are bad?
No,
Dr. Clarey.
This was better than some.
Oh.
There's nothing bad. It's just.
You were prepared for this one.
No, I had a better answer maybe.
Speaking of then this more biblically grounded worldview, we know that given current erosion rates, just our planet can't be as old as they say it is. So where does erosion fit when it comes to a biblical time scale? What role does it play in getting the Earth to where we see it today?
Well, we see the evidence, especially when you look at like air photos and you get up and look at satellite views, you can really see that there's areas of the Earth that have experienced lots of erosion, where you can see just material's been stripped away, and you can almost see the transport directions by where the sediments end up in the oceans. So you can see thick areas in the oceans, with oil well drilling, and tie it into what we can see from looking up kind of the big picture view, the bird's eye view, you can see major areas that eroded and were stripped away and material was transported. You might not be able to tell the exact time, but you can see a common direction, a common buildup. But there's a lot of evidence of massive erosion, which I think most of that took place probably in the receding phase of the flood.
Okay. So according to, I guess, ICR and your view of this progressive flood, it goes up to day 150, it reaches the top, then it starts to recede. And so like during that receding phase is when major erosion takes place.
Probably in some places tens of thousands of feet of erosion, especially as the mountains were coming up. And so all those sediments that went over from one side of the Rockies to the other, there might have been 5,000 to 10,000 feet or more of sediment, that was all stripped off. In many places right down to the crust, right down to the crystalline Precambrian rock, we call it in most cases. And so we knew we can actually measure from one side of a mountain to the other, and you can get a pretty good estimate of the same material is probably going over the top or something close to it. And so you can estimate how much erosion. And so there's been a lot of erosion in a very short amount of time in terms of the biblical time frame. But it all seems to be, the best explanation for that would be the flood, the receding phase of the flood. Because
as you mentioned, there is ice and there is air, sort of, but the main factor in erosion is water. And so if there was, which we believe there was, and the evidence points that direction, if there was a global flood, that would cause the erosion that we see.
I think most is at the surface anyway today.
Okay.
And the reason there's not much erosion today, it is like 40 feet per million years or whatever the current rate seems to be, is because there isn't a major receding phase. There isn't, the land continents weren't flooded anymore. They've all drained away. So now we just have kind of going back to the normal hydrologic cycle that we see, occasional really heavy storms and landslides here and there occasionally. But there's no big major event that's going to really wash away tremendous amounts of rock and material on a regional scale.
Right.
You get some local ones here and there, but there's no activity really that's going to erode away on a regional scale. But even that, like I said earlier, even that slow erosion is too much for what we see. Most of the continents should be gone. Just like the Hawaiian Islands should be gone, the continents should be eroded right down to sea level. Much of them.
I was about to say, like,
except for the rescuing device. You can argue the Rockies and the more recent mountain ranges, which most of them happened during the receding phase. Those would probably still be there. But most of the flatter areas, the Midwest, the East Coast of the United States, east of the Appalachians, there shouldn't even be there.
There wouldn't be enough room for humanity to live.
And again, they don't have a rescuing device to argue, there's tectonic uplift to keep them above sea level. And it's the same way in most of the continents of the world. There's no, Africa doesn't have a lot of tectonic uplift. There's no big Andes Mountains or Rockies running the length of Africa, so it shouldn't be there. But you see all this evidence of erosion, massive erosion, these planation surfaces that my colleague and friend Mike Ord talks about, he sees all over as evidence of erosion, massive erosion at some point in the past, which we, again, think is the receding phase.
Okay. So the flood answers it.
The flood's the best explanation for what we see. It's just people don't want to think about it. The geologists, the uniformitarianists, the whole idea of starting with Hutton and many of the 19th century geologists started pushing the Bible out, trying to separate the Bible from science. And in fact, the Bible and science actually match up perfectly when they look at the data and just look at the data, not an interpretation of the data, but the actual data itself does support a young Earth with one major period of massive deposition and then massive erosion as the water went up and as the water went down.
Okay. All right.
And there's a lot of features out there, like you talked about, cliffs, waterfalls, all these things that are showing us this landscape is youthful. It's not that old, because that would have smoothed all that off.
And a lot of it's really intriguing, and it's almost like these, like, I guess we can call them like flood remnants almost, or like beautiful, I think of in the Old Testament when God tells the Israelites to set up stones so that you will remember your God, your children will remember your God. I think I see some of those and I'm like, God's reminding us of what actually happened.
I think that's what Grand Canyon kind of is. I was just out there with a group of people, and And I think it's almost like God ran his finger down there as the water receded and carved it out and said, now look at all these layers, and look how they're just stacked on top of each other like pancakes. And knowing that future scientists would say there's going to be millions of years between this layer and this layer and this layer, they say, look, here it is right before your eyes, these rapidly deposited layers, and then rapid erosion to expose them all. We see that all over the world. There's major canyons at that same level all over the world, many of the continents. And you don't see those canyons before that level. It's all at the end, just what you'd expect in a global flood.
Awesome. Well, I know that you've done a lot of work along these lines. You have a book called Carved in Stone. You have a DVD called Carved in Stone.
Yes, it just came out.
Well, when this releases,
physical copy isn't out.
Yeah, when this releases, it would have come out in December of 2023. So I think it'll have been out for a month or so. But we'll go ahead and plug it anyway. So get your copy today. Do you have any final thoughts? Any wisdom to impart to our viewers and listeners?
I don't know about wisdom.
What about that Michigan wisdom, Dr. Clarey?
Let me I don't know if it's any different than any other state, but nonetheless, I think the wisdom here is that the Bible talks about a creation. The Bible talks about a flood, and to me, the age that's pretty clear in the genealogy. It tells us it was only thousands of years ago, not millions and billions, and the evidence that we see in the rocks all supports thousands of years ago that there was a major global flood just thousands of years ago as well, not millions or billions as the conventional or secular community says. Okay. So there's a lot of evidence. It isn't like science and religion conflict. Science and the Bible don't conflict at all. They actually match up perfectly. When you look at the rocks themselves, right, not looking at the interpretations, when you're looking at the erosion rates that we see today and compare them to what happened in the flood, that's what we see. We see slow today, but there was a period of very, very rapid deposition.
Especially when the idea of those long years came from someone who was trying to get rid of the biblical account.
Right.
Yeah.
And all these cliffs, all those are things that tell us this landscape is young.
Yeah.
All these waterfalls all over the world, cliffs, and those should have eroded away. Yeah. Just like a lot of the continents should have eroded away. So the evidence is there. We just have to kind of open our eyes and get in tune and look for it.
Yeah. Okay. Not everyone's a geologist, so yeah.
You don't have to be. Yeah. Even the things I talked about today. When you see a waterfall, you think, oh, that cliff shouldn't be there. It can't last millions and millions of years.
So now I expect our listeners and viewers leave a comment with your favorite geologic evidence of a young Earth, and if it's incorrect, I'll talk to Dr. Clarey about it, and we'll reply to that. But yeah, so young Earth, young rocks, erosion rates show that it can't be that old. So thank you.
That's correct. Thank you.
And to all of our listeners and viewers, thank you so much for joining us. We ask that you like, subscribe, share this video with your friends and family. If you have any questions, leave them in the comments and I will get them to Dr. Clarey so that he can answer them. And we also, if you want to receive this podcast a week early or watch creation.live 2 weeks early, you can always become a member. You can join us here on YouTube or on Patreon. We have lots of different perks, different tiers. So give that a look. Links are in the description. And of course, I've been Trey, and we'll see you next time on the Creation Podcast. We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.